All right, welcome to the first lesson of Unit 3. So here we're going to dive into more differentiation. So we spent the last unit talking about the definition of a derivative. We looked at some situations where the derivative won't exist, where it will exist, what are the criteria for that. And at the very end of the unit, we started looking at some more real-world applications and also at finding some rules for calculating the derivative without actually having to take the limit definition every single time. And the rules that we talked about were the constant, sum, difference, sum or difference, two different rules, and the power rule. And so today we're going to start off Unit 3 by reviewing a couple of them and extending our definition of the power rule to include more than just positive integers. So let's go ahead and get started. All right, so to start us off, why don't you go ahead and state the constant rule, the sum and difference rule, and the power rule of derivatives. And you might want to go back to your notes to check those out and make sure that you can state them again. Use some shorthand notation, so you don't have to rewrite them all over again, but just in a very quick way, show that you know what those mean. And then take a look at number 2, copy that down, and try that out. So those are the constant, sum, difference, and power rules, right? If I take the derivative of a constant value, like, for example, 7, well, that's just a horizontal line, and so the slope of that line is 0, so the derivative of a constant function is 0. The sum and difference rule, I need that minus there, is saying that if you have two functions that are both in terms of x, and you're adding or subtracting them together, and you want to take the derivative of the whole thing, that you can split them up. You can take the derivative of each piece independently and then add or subtract it to the derivative of the other piece. And then the power rule says that if you have some function where you have x to the n power, where n is a positive integer, the derivative of that is n times x to the n minus 1. So as an example, if you took the derivative of x cubed, you get 3x squared. And if you move on to number 2, and you notice these here are some creative ways of writing an exponent. This is really taking the derivative with respect to x of x to the negative 1. And if you applied the power rule, you'd get negative 1 x to the negative 2, which can be rewritten as negative 1 over x squared. Now, if you go ahead and use the limit definition, you can confirm that this is in fact the correct answer. Here, this is taking the derivative with respect to x of x to the 1/2. If you apply the power rule here, you get 1/2 times x, and then 1/2 minus 1 would be negative 1/2. And if you were to then drop that down into the denominator, you'd have x to the 1/2 in the denominator, which is just the square root of x. You'd have 1 over 2 times the square root of x. And that seems like a lot easier of a process, right? If you go and you confirm your answers using the limit definition, you should get the same value. But just think about the time that you're saving. So wouldn't it be nice if the power rule, we could define the power rule for both negative and for fractional exponents. The power rule for derivatives states that for any real number n, the derivative with respect to x of x to the n is n times x to the n minus 1. And we've seen this before. We saw it for positive integers only, and we talked a little bit about what would be the case if n were a negative integer, and now we've wrapped it all up so that even if it's a fraction, you can apply this rule. And so we'll go ahead and start doing that. And so I've given you a couple problems to practice with, and if you are into those problems, you want a few more, I'll also write down a couple of extras that you can try on the side. Alright, so go ahead and work through problems 1 through 4 on your own. Make sure that your solutions make sense. Have a completed and final answer for each so that you can present in class. And then if you want a little bit of extra practice, which I highly recommend, take a look at page 126, numbers 29, 30, 32, and 35.